In this video, we're going to talk about the external rate of return. The external rate of return is not nearly as widely used as the internal rate of return, but it should, because it's actually, it makes a lot of sense to those of us that understand the internal rate of return to begin with. But the thing about the internal rate of return is what it is, it assumes that the revenues generated are invested at the IRR, which may not be an accurate situation. That's common, but sometimes unrealistic, especially when we have a project that has a very, very high IRR. The probability that we are able to just reinvest money at that rate all the time is just not plausible sometimes. What the ERR does is it takes into account the interest rate. Here they call it E like epsilon. External to a project at which net cash flows generated or required by the project over its life can be reinvested or borrowed. This number is usually the MAR, so sometimes we have to use a different rate, a more realistic rate. Now, if the ERR happens to equal the project's IRR, then using ERR and IRR produce identical results. So what is the procedure like? First of all, we're going to discount all cash outflows to time zero. So all cash outflows, all costs are coming back to the present using epsilon percent. While we're going to compound all net cash inflows to period N at that same rate. So at this point, we're gonna find right at this step, we're gonna find our inflows right over here and our outflows right over here. So this is N and this is 0. Okay, so how would that be helpful? Well, we have then one more move, and that is to solve for the ERR, the interest rate that establishes equivalence between these two quantities. So, oops, I moved too fast. So in other words, we're going to then move this over here, and that rate at which this is equal to that, that's our I, the I that we are looking for. So this is my my equation right here. So we are going to bring, and actually in the past I said that we would be doing it, bringing this here, and actually it's not incorrect, but the formula, what it's saying is everything is going to meet over here. Both ways work. But just so you don't get confused, what this is doing is taking the excess of expenses over receipts in period K. So this is money going out. We're moving it to the present at E, or this epsilon, and then we're taking it to F, to the future by this rate. And then this one is gonna be going into the future from wherever it is. It makes more sense with an example. So let's apply the ERR method. For the cash flows given below, find the ERR when the external reinvestment rate is 12%, which is the MAR. Okay, so we have here a cash flow. Let's see, we have two numbers going out. This is coming in. So in this case, my expenses, let's send them to the present, and that's 21,250. My revenues, they are an F given A. Let's send them all the way to the future. So at this point, I have arrows that look like this. This is period 0, and this is 4. And this right here is 33,744. And this right here is 21,250. And then we are going to solve by finding how we can take this into the future. What rate will make this equal to that? And we find that the rate is equal to 16.67. And since it's greater than the MAR, that is a good investment. So let's do an example. Let's do an example 3 from the past. Or was it 2? I can't remember anymore. No, it was 3. But with an external interest rate of 10%. Oops. Okay, so if we remember that one was the one that looked like this, and it had, oops, a gradient that started with 5, 10, 15, 20, and 25. And this was 42.55. So now the difference is I am going to send this 42.55 to a future period. Well, first of all, to present, but it's already in present. So this is what I'm looking for. It's like a prime. 5 periods. So that it is equal to this in the future. Now, I don't have an f given g, so what I'm going to have to do is first find p. And to be honest, this is sort of unnecessary. We could have made everything, we can move things in different directions, but this is staying consistent with the formula. So then I'm going to send that to f given p at this rate, at 10%. This all comes from here, there, for 5 periods. And if I do this, I'm going to find that f given p with this percentage 5 is equal to, so I'm going to solve this and I'm going to divide by that, which is 2.016, and I'm going to find I, and I is equal approximately to 15%, which I don't have a mar in this problem, or I did actually. What was the mar in this problem? I would have to go back. I think it was 20, so it's still less, so it's still not a good investment, but it is not the number that we got before. Before it used to be 17.41. Okay. We're going to continue with payback period in the next video.